Electrons which are revolving around the nucleus, which is the potential energy is equals to 2 times of kinetic energy, because kinetic energy is what? X by 2. X by 2 plus X by 2, if you take 2 times, double it is. So then only we'll get it what actually potential energy. Am I right or wrong, everybody? Please respond, guys. All of you. Yes or no? Do you understand, brothers? So
Sir.
if I multiply with the 2 times, then 2 will get cancelled. I will get minus of. I am writing minus of. So minus of 2 times of kinetic energy. What is the kinetic energy? X by 2. So 2 will get cancelled. I will get minus x. Minus x is a what? Potential energy. Am I right or wrong? Everybody. Next, total kinetic energy. What is the total kinetic energy? Positive. 2 times of total kinetic energy is what? Minus x by 2. So then, what will happen, everybody? Again, 2 will get cancelled. Minus x will come. So, got the answer or not? Potential energy. So, potential energy of any electrons which is revolving around the nucleus or satellites revolving around the Earth. Always the potential energy is 2 times minus 2 times of kinetic energy or 2 times of total energy. Okay, Rudreshwar, clear? Understand, everybody?
Yes, sir.
Yes. So you remember, whenever the any kind of satellite or planet which is revolving in a closed path, that is what we used to say, either it is a circular track or it is an elliptical track. So always the total energy of a system is negative. But if you see, at the certain situation where the total energy equals to 0, that is what we can say free system. If the system become free when the velocity reaches to the escape velocity, when the velocity reaches to the escape velocity, where escape velocity is equals to root 2 times of orbital velocity or root 2 times of, we all knows that, gm divided by r. That is what. So at this situation, total energy will become 0. The total energy of a system becomes 0. So by that time, we all know that the satellite will take what path, everybody? It will take a path, particular path, which is equals to what? Parabolic path. Parabolic path it will take, where the total energy of a system become 0. It will never reaches to the Earth. Now, if the total energy of a system is positive, that is what? Where the velocity is greater than 11.2 kilometer per second. That is what is escape velocity. So this is also called it as a free system, open curve, free system. So by that time, the satellite or whatever it is, it will go in a what path, everybody? It will go in a hyperbolic path. So that is what hyperbola path it will be taken, where total energy of a system is positive. Equals to 0, parabolic path. Less than, that's what 0, less than 0, that's what negative means, closed path. And positive means it will be hyperbolic path. So this is what is about what is the energy of a satellites, what is the time period of a satellites, what is the orbital velocity or speed of a satellites and everything. So I hope you all understand. So anybody having any doubt, you can ask me in this. If not, and we are going to study the last concept of this chapter. One more concept is left. That's what? Proof. Verifications of Kepler's 3 laws. I taught you what is Kepler's 3 laws. Everybody remember that? All of you?
Yes, sir.
Yes. So now Kepler's 3 laws you remember, but verification is left. That verification alone we will study some other time. So now you remember, based upon this time period, based upon the orbital velocities, based upon this NEET, 100% there will be a question every year, and JEE mains compulsory, JEE advanced also majority of times. Many years, alternative years at least, or 3 years once they asked the question from this in the JEE advance also. So that is what high priority concepts of this gravitation is entirely having more importance. Okay. So now types of satellites. This is the last concept of us. So types of satellites. So what is this satellite types and how it will be classified? We'll make it. So we all knows that whatever it is, either it is a planet or it is a satellite, based upon the distance present between them. If the satellite is revolving around the Earth very, very far, then time period also increases or decreases. Everybody? Yes, please, guys. Suppose planet, one satellite is revolving here, another satellite is revolving here, another satellite is revolving here, another satellite is revolving here. Does it all the satellites will take the same time to revolve around the Earth? That's what is my question. Everybody?
No, sir.
No. So keep it in mind, we all knows that Kepler's third law. Square of time period is directly proportional to cube of distance between the satellite and the Earth, or planet and the sun, like that we studied. So if the satellite is moving far away from the sun, far away from the Earth, then time period is also increases. That is what? Time period is directly proportional to R. The distance between the objects, two objects, is keep on increases. Then the time period, the time taken to revolve around the Earth is also increases. So based upon this, on the basis of the types of satellite is purely on basis of altitude, how much above from the Earth, and as well as based upon the time period, how much time it is taking to revolve around the Earth. Based upon these two things, we have classified the satellites into three different types. That's all it is. One is LEO, another one is MEO, and another one is GEO. So three types of satellites. LEO means, all of you remember, LEO means lower Earth orbit. What is that, everybody? Lower Earth orbit. So how much, sir, lower Earth orbit? Observe, brothers. If the above from the Earth surface, if the satellite is revolving between the 200 kilometers to 2000 kilometers, what is the radius of the Earth, everybody? Radius of the Earth is how much? 6400 kilometers. Am I right or wrong? So if any satellite is revolving around the Earth between 200 kilometers to 2000 kilometers, that is what we used to call it as a lower Earth orbit satellites. So majority of the satellites which is launched by any country, many satellites, most of the satellites will revolve around that. In this range only. That is what is our Indian satellites, or any kind of satellites which is launched by majority of the countries is in this region only they will revolve. Next. So if you notice it here, what is the time period to make the complete revolution around the Earth, which is approximately for these satellites, which is approximately 1.5 to 2 hours time. So if you take averagely 2 hours, then per one day, how many revolutions they will make? Per one day. One day they will make how many revolutions approximately? All of you. Yes, please, guys. 12 revolutions approximately. Why? Per one day, how many hours? One day, how many hours? 24 hours. Understanding? So these satellites, LEO satellites, the satellites which are present less than 2000 to 20,000, sorry, 200 to 20,000 kilos, sorry, 2000 kilometer. Per one day, how many rotations they will make, everybody? Per one day, approximately 12 rotations they will make around the Earth. Most of the satellites under in this region only. So now, if you have taken here, next MEO satellites, middle Earth orbit, that is what there will be. Middle Earth orbit. So these satellites will be approximately, the height is 2000 kilometers to approximately 36,000 kilometers. So means, for example, if I consider basically, most of the MEO satellites are considered at the 20,000 kilometers above from the Earth. So means if I consider the Earth around 20K, around the 20K above 20,000, 20K kilometers above, most of the satellites revolving around the Earth. And for these satellites, so there is a different purpose for us. The time period is approximately 12 hours. How many hours, everybody? How many hours? 12 hours. Means per one day, approximately how many rotations they will make? How many revolutions? It will make approximately 2 revolutions will make, 2 rotations. 2 rotations per one day around the Earth. Now last one, the satellites which we are communicating, telecommunication, signals, whatever you can see, movies and all you can see, the signals will be transferred to the satellite and then only it will be reaching to us. Do you remember, everybody? Our dish antennas, cell phone towers, dish antennas and all. This all the things are the geo. Because if they are at the lower levels, then definitely the signals will intercept. They will be mismatched the signals. That's why the satellites which are revolving around this, the technologies, like we can say, almost if you consider this, all the telephone communications, dish antennas and all, this all the things we used to call it as a geostationary satellites. What is that? Everybody? Geostationary satellites. So which are approximately present, remember, 36,000 kilometers. Approximately, they are present geostationary orbits of approximately 36,000 kilometers above, and they will take 24 hours to revolve around the Earth. Means for one day, how many rotations? Everybody. For one day, how many rotations, guys? Please respond. They will rotate approximately one rotation per one day. So imagine like this, if you consider LEO, MEO, GEO satellites, then moon. What about the moon? Moon is present extremely far away from the very, very larger distance away from the Earth. So it is more than that many kilometers. If I consider this is the Earth, so LEO satellites are here. That is what, up to 2000, and MEO satellites are up to 36,000, and GEO satellites are more than 36,000, and moon is present very, 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 very far. So more far away from these MEO satellites. So it is extremely far away from the Earth surface. So that is what is where moon is present. Moon is revolving around the Earth extremely far. So that is why, what is the time period of a moon around the Earth? Anybody can tell me? Time period of Earth, time period of a moon around the Earth. Guessing? Yes, please. Anyone? It is? Please respond. Which is approximately how many days? Pradosh? Earth will take how many days to revolve around the Earth? Revolve around the Earth. Approximately 27.3 days. It will take to complete one revolution. So imagine the satellites which are at GEO itself will take how many hours actually? 24 hours to take. Means for one day, they will take one revolution. But moon is taking 27 days, approximately 1 month. 1 month per one revolution. Means then extreme, how much far it is. Can you able to imagine, Mr. Rudreshwar, how much far the Earth is, Pradosh? How much
Yes,
far the moon is present? It will take almost, okay, so it will take almost approximately 27.3 days, or it will take complete revolution. That is what, from new moon to new moon, one new moon to new moon, one new moon, what we are saying to the another new moon, approximately 29.5 days. That is what, approximately 1 month it will take to complete one rotation around the Earth. Means imagine how far the Earth is present. Sorry, how far the moon is present away from the Earth. I mean, lakhs of kilometers away. So this is what is about it, the types of satellites and the antennas. The dish antennas, if you notice it, the dish antennas, what we are working, everywhere the satellite signals which are present, the satellite signals what we are getting is everything the satellites which are present at geostationary orbits. Geostationary orbits. From there only the satellites communication, everything will be functioning. All the signals and all, dish antennas and all will be present. And these satellites which are taking 24 hours to complete one rotation. And you remember what is the height, everybody? They are present above how much? 36,000 kilometers above from the Earth. And you remember, they are always rotating about the Earth at the equator belt. They are not at the poles belt. They may be rotate in the inclined in this orbit, or they will be rotate in the equator belt, not the poles belt. So this is the position of these satellites, geo satellites around the Earth. So they are always revolving around the Earth at a equator belt. That is what you have to remember. So this is what is the satellites which are revolving at the Earth at the equator belt. Also we can say that synchronous satellites. So geosynchronous satellites whose time period is 24 hours and height is 36,000 kilometers. So this is what is about geostationary satellites, which we are using for telecommunication or the electric signals. Everything is that only. So they are always revolving around the Earth. 24 hours they'll take, and they are revolving in equator belt. That is what you have to remember it. So this is what is about the gravitation concept, and only one concept left, that is what? Kepler's laws, verification of Kepler's laws. So other than this, all the concepts I have covered everything. So once the exam's over, you need to spend time for practice. I think exam gravitation also there for you. Am I right? All of you?
Yes, sir.
Yes. So, okay, that's fine. Then you prepare for your exams, and whenever time permits, and those who do not have exam, Princey, you have to use this week for practicing completely whatever your incomplete works are now. Okay, Princey? It is over.
Okay.
Then, as I said, once the class 10, the classes will start. That's what exams will start. Even morning schedules also, some days, whenever the time permits, we'll try to take and we'll try to finish the volume 2 as early as possible. Okay, Mr. Rudresha, use the time wisely and prepare well for exams. I need marks, every subject mark I need in our mid exams. Okay, so kindly focus well and do it everything perfectly. Thank you, everybody. We'll meet soon. Thank you, everyone.
Thank you, sir.